So, hello everyone. So, my name is Raphael Silva. I'm a software development engineer at AWS in the AWS distro for OpenTelemetry team. And today we are going to talk about histograms in the context of OpenTelemetry and what is the current state of histograms. And so let's get started. Let's get started with an overview of what we are going to talk about today and the context. So yes, we already know, but OpenTelemetry is a vendor-neutral open source framework for observability. And it's composed of some elements. So between them, specification, API and SDKs that are implemented across several languages, a protocol that's used for transferring telemetry signals between elements in an application or system, and tools, for instance, the collector. So OpenTelemetry allows us to have full observability because it provides us with tools and APIs and SDKs to instrument applications for trace, logs, and metrics. So today we are going to focus on the metrics part. But first, let's talk a little bit about how a field application using OpenTelemetry looks like. So we have an application that can be implemented across several languages, and this application can be using a library that has support to OpenTelemetry. And this application can also instrument the code using the OpenTelemetry API. So the signals produced by the API are then collected or configured through the SDK, and those are exported by OTLP exporters to the collector, and the collector will transform and process these telemetry signals and then send it further to backends using either the OTLP protocol or other protocols. So the collector is kind of a point of convergence and kind of a compatibility layer between legacy and new applications. So that's why we have here in this diagram some legacy applications that can be talking other protocols, and the collector will also be able to process signals using other protocols. Okay, so focusing specifically on the metrics. So the OpenTelemetry define APIs and SDK to be used by applications or libraries. So the API define interface for implementing the applications, and the SDK is what provides the real implementation. Specifically for the metrics API, we can talk about three elements that the metrics API provides. One is the meter provider, which is configured by the SDK, and then it holds configuration for meters. Meter is what creates instruments, and instruments is the entity that are used to record measurements. So OpenTelemetry defined three types of instruments: counters, which are used to record monotonically increasing values, for instance, the number of requests that a HTTP server might get; a gauge, which is typically used to record state, so for instance, the CPU utilization in a host; and finally, the focus of this presentation, histograms, which are used to record the distribution of recorded measurements. So histograms will, for instance, allow us to calculate the latency in applications. So the agenda for today, we are going to talk briefly about what's histogram, define it formally, and we are going to focus on how histograms calculate percentiles. Next we are going to talk about the types of histograms defined in OpenTelemetry, and in the end, we are going to do a little walkthrough to talk about the OpenTelemetry APIs used to interact with histograms. And we are going to use Java for this code walkthrough. So here we have a histogram. So in this case, this histogram is recording the distribution of request latency in a HTTP server. So A histogram is composed of bins or buckets, and each bucket has a range. And how it works is that the histogram will record the frequency of observations that fall within a range. So, for instance, for this range here, from 100 milliseconds to 500 milliseconds, we have 800 observations that will fall within this range. Doesn't matter what exactly is the exact value, so that's the main property of the histogram. It's an approximation, and so this property of compressing the data with compressing the observations, something very nice to have in the observability space. It allows us to compress a high number of observations in a constrained data structure. So let's say in the example before, there were 2,000 observations that were compressed in 9 buckets. So each bucket in the end is it can be implemented as a long, and therefore we are compressing a lot of data in a very well-defined space. And another property that's interesting for in observability is that we can combine multiple histograms. As long as they are compatible, we can combine them by doing the sum of the buckets that fall in the same within the same range. And finally, histograms simplify the calculation of performance metrics like the tail latency. And by talking about tail latency, we are going to do a little walkthrough about how to calculate percentiles, which allow us to calculate the tail latency. So for instance, if we have a HTTP server and we want to calculate the tail latency, let's say the P99, using histograms, we can determine what's the bin that falls. The algorithm is like this. We are going to walk through the bins. Sorry, I missed one step. First, we need to define what's the target. So the target is this Q multiplied by the total number of observations in the histogram. And then after we get this rank, we can iterate over the buckets, accumulating the number of observations until we get into a point where the count is greater than the rank, greater or equal than the rank. And then at this point, we know that in a specific bin with the observation for that percentile will fall in. And then finally, we apply a linear regression to get the approximate value for the percentile. So here we have the formula for calculating the linear regression. It's a simple linear regression using line curve equation. So here we have a visual representation of the algorithm that we just talked. So as I mentioned, we are going to iterate over the buckets. Once we find the target bucket, we can then calculate using linear regression what's the percentile. So for instance, P90 in the example before will be 1,500 milliseconds. So this is what Prometheus uses under the hood to calculate the percentiles for us. So moving to the next topic. So OpenTelemetry defines 2 types of histograms. The first type is called explicit bucket histogram that define bucket boundaries explicitly. And the second type is called base 2 exponential bucket histogram. So it was recently renamed from exponential bucket histogram. So now the formal definition as it is written in the specification is base 2 exponential bucket histogram. And this one specifically uses a base 2 exponential formula to determine the bucket boundaries. So focusing specifically on explicit bucket histograms, as I mentioned, it's defined explicit bucket boundaries. So OpenTelemetry define that explicit histograms, they have these default values for the bucket boundaries. Reason why these values were chosen was because it's optimized for a variety of applications, including record latency in HTTP servers. And bucket boundaries can be changed using views. So we are going to talk about a little bit more about this later. And the status of this type of histogram in OpenTelemetry is stable. So what does that mean? Is that now the APIs for interacting with explicit bucket histograms, they are stable and they cannot be changed unless there is a backwards compatible change. So this is an important thing to notice. Means that if you are coding your application using this, since OpenTelemetry is very new, that's the community is guaranteeing that they are not going to change the APIs. So the other type of histogram is the base 2 exponential histograms. So as I mentioned, this one compress buckets boundary using exponential formula. So how does it work? Is that you have to define a resolution for this type of histogram that's characterized by a scale parameter. So the scale parameter will allow you to calculate what's the base of the histogram. And then we have this formula here, 2 to the power of 2 to the power of 1 minus scale. And the bucket range, they are defined in this way. So we use the bucket range can be calculated from the index of the buckets, which is a nice property. So one interesting thing to notice about this type of histogram is that they are always compatible one with the other. So let's say histograms of different scale, they are always compatible. What will happen is that if we need to combine histograms of this type, they will the resulting histogram will have the same resolution as the histogram of the lower resolution. So this is what we are visualizing here in this table. So in this table here, we have the colors representing the bins in each histogram, and the numbers represents the range. So we can see that the range of the histograms of different scales, they are always compatible with each other. And one interesting thing to notice is that this type of histogram was made stable very recently. So yeah, so this is something very new that was stabilized not long ago. So now we can get the nice guarantees about stability, and we can use these type of histograms without any problems. Okay, moving to the practical part of this presentation. We are going to talk about how to use histograms using OpenTelemetry, using the Java language. So we are going to cover some steps here. We are going to talk about SDK initialization, how we create a default histogram without defining any boundaries. And next, we are going to see how we can use views to change bucket boundaries. And finally, we are going to show how to use exponential histograms, base 2 exponential histograms. Okay. So a little bit of code here. What we are seeing here on the screen is the initialization of the SDK in Java. So the first thing that you might want to do is to create reserves. Reserves are an entity that only results are entities that only exist in the SDK. There are immutable representations of entity producing telemetry data in the form of attributes. In practice, how this works is that resource attributes will be available in the telemetry signals that you produce in the end. They will be injected in those signals. So, for instance, we are going to see next that, for instance, the service name property will be available in the histogram that we are going to create next. Okay, next step is to create the exporter for the data. As we saw in the beginning of the presentation, we are going to export data to the collector using OTLP over HTTP. We need to define how we are going to flush metrics to the exporter. And in this case, we are going to use a metric reader, which will periodically read the metrics and then flush it to the exporter. Next, we define the characteristics for all meters by defining the meter provider. So this meter provider doesn't have many, right now, doesn't have many customizations. We are just setting the resource and then registering the metric reader that will be used by it. And finally, we initialize the OpenTelemetry SDK, and we register it as a global OpenTelemetry SDK. So this one is important because this registering the global OpenTelemetry SDK is something that allows us to decouple the application from instrumenting libraries. In case the library implements OpenTelemetry instrumentation directly, it will allow the instrumentation library to get the instrumented library to just try to get the global OpenTelemetry SDK that was registered globally, which is what we are seeing here. So after we get the OpenTelemetry SDK instance, we create a meter. The meter will be created based on the meter provider that we define in SDK. And finally, we create a histogram with some properties. This histogram is of type long here. And last but not least, we record the observation in the histogram. And optionally, we can provide attributes that are related to this measurement. Okay, so how does this materialize, let's say, in Prometheus? So the histogram, in this example here, the histogram that we just saw in the code was exported through the collector to Prometheus, and here are the properties of this histogram. In Prometheus, this histogram will be decoupled in the buckets. A metric for the buckets, one for the counts, and one for the sum of the values that were recorded. And as we can see here, even though we didn't define the bucket boundaries, we are getting some bucket boundaries here. And so those bucket boundaries are the default values that we talked before. Also, we can notice the other the attributes that we define, like the name of the application, in this case, the job. You can see here the SPOTcon demo for the value. And the other attribute that we defined before was the method used for the HTTP method that was related with this observation. So in this case, a get. Okay. So, but how do we change the bucket boundaries for histogram? So this was an interesting design choice of OpenTelemetry developers. You cannot access this directly to the histogram object. This is a configuration that's performed in the SDK level during the initialization of the SDK. And for that, we have to use an entity that exists in SDK. It's called view, that allows users to customize the metrics and how the metrics are outputted by the SDK. A view is applied to a meter based on a set of matching rules. So the type of instrument that view should be applied, the name of the instrument, and the name of the meter. So again, doing the SDK initialization again using the view. We are building here a view, and we are defining explicit bucket histogram with 3 buckets, plus the infinite bucket, which is implicit. Then we are going to define an instrument selector, which is used to define to which instruments this view should be applied to. So the OpenTelemetry SDK allows you to specify, to use wildcards and question mark to replace characters, so that you can apply this view to a range or to a set of instruments that share the same prefix. And in this case here, we are applying only to instrument type of histogram. And then we have to pass this instrument selector in the view when we register the view in the meter provider. And there are no major changes in the part that in the application side where we get the meter and the instrument. Okay, so yes, if we take a look into what is exported to Prometheus again, we can see that this histogram, it has only 5 buckets, which match what we defined before, and yeah, the rest remain the same. Okay. So for base 2 exponential histograms, the mechanism for defining them and using them is pretty much the same. We have to use a view to configure the type of histogram aggregation that will be used to hold the data in a histogram created by the API. So again, we just create a view, and and we set the type of aggregation to base 2 exponential histogram, and we define what's the number of buckets and what's the resolution that this histogram will have. Okay, yeah. Unfortunately, this feature is only experimental in Prometheus, and I couldn't get it in time for this presentation. And so we are getting to the end of this presentation. I'm leaving here as reference for bedtime read to take a look into the OpenTelemetry specification for APIs, SDK, and data model for metrics. I think we are much more familiar with the concepts that we talk now, so we can go and take a look into how those are defined in the specification. And that's it. Thank you very much. I guess now we are open for questions.